Let's take a look at how we can use windowed aggregation with watermarks. We're going to build a couple of data frames that use time window aggregates with a watermark. And we're going to also talk about how we can put the data in a delta table using update mode, as well as for each batch, which we'll talk about. And we'll talk about monitoring the streaming query as well. Here are the classes that are used. I have links for you as needed. I'm going to go ahead and run the classroom setup script as usual. This one won't take as long because I've already got all of the data installed in my workspace from the last time I ran this classroom setup script. So I'm going to essentially build a starting out data frame, right? So it's my initial streaming data frame with a delta format file source. So I'm going to capture this as parsed df. I'm going to read stream from my da.paths.events path. With my column event timestamp, I want to have this event timestamp. I'm going to use the current event timestamp, divide that by, what is that, 1,000,000 or 1,000,000,000, something like that, whatever that is that we need to divide that by, and then cast that as a timestamp, which is going to give me a proper timestamp that I can use in future requests and future queries. With my event previous timestamp, I'm going to do the exact same thing, cast as a timestamp, and write that back to my event previous timestamp column. And in the case of my e-commerce.purchase revenue in US dollars, I want to make sure that I filter out anything that is null or making sure that I have US dollars that are not equal to zero, right? Just to make it a lot easier to filter out zero revenue results as well as anything that's null. Let's go ahead and display this data frame. Now, notice that this is a streaming data frame. And so we're going to get output when we perform the action, right? Which is in this case, to display, right? So I create the data frame up here, but I don't see it because I haven't performed any action on it. I've just defined it. And notice also that we're going to get the output, but we're going to continue to have this data frame streaming until we specifically ask it to stop streaming. We can see the data here before I move too far away. There's my event previous timestamp and my event timestamp, which we've taken care of as we've parsed that to a timestamp. And then let's take my window data frame. Now I'm going to go ahead and run this, and then let's talk about it as this streaming data frame is being produced and displayed for us. So what we're going to do is we're going to take our parsed data frame, the one we just barely instantiated up above, and we're going to, we want to add up the revenues based on a 60-minute time window, right? So we're going to set a watermark there, and we're going to base that on the event timestamp column with a delay threshold of 90 minutes. Which means that we are going to calculate based on a 60-minute window, but we're okay waiting for late arriving data to continue to increase or change that aggregate time window based on 60 minutes. In other words, we have a certain amount of time where data might be coming in late, where it can still affect the outcome of that time-stamped 60-minute window. Because this is a tumbling window, we're not going to get any overlap in this. It's a 60-minute window that's going to occur, but we're going to wait for late arriving data as well. So what we'll do then is we'll group by the geo.city, right? So the city field within the geo column based on a 60-minute window duration of our event timestamp. So we'll group by both of these, the 60-minute timestamp window as well as geo.city. We're going to aggregate based on the sum of the e-commerce column, the purchase revenue in US dollars field within that column. We'll alias that as total revenue. Here's the results now. We see we're still streaming. We get a window, and notice that these windows are all about 1 hour. Not about, they are 1 hour. We can see here that if I open this up, start and end, we can see that I have, what is this, 6/27 of 2020, or the 27th of June 2020, depending on what country you live in. This is going to refresh every time that stream updates, so that's going to close back up. But you can see I've got a 1 hour time window here. Here's Fresno, right? $903.60. I'll have other Fresnos in the city field, but with different windows of time, right? So each of these is 1 hour. I will also group by the city, get that total revenue or the sum of that total revenue within there. Now, how can we write these results? We can write them in two different ways. We're going to talk about append mode first. Let's go ahead and get this running. I'm going to go ahead and run this, get this stream initializing and taken care of, and let's talk about it. So just like we did before, we're going to provide a checkpoint path based on my da.paths.working directory and then a subdirectory here, query revenue by city by hour append. Now, the thing is, writing in append mode, one of the things I want you to keep in mind is that this data is all older data, right? This is from 2020, which is now a few years ago, and it's older data. If you are windowing with data that is continuing to come in, then the window has to expire before you can write in append mode. So in other words, if you have data that's arriving and the hour's not up yet, you're not going to get a write to this output table, the sync, until that append time for that current time window has expired, and then it's going to be written. Since all of this is old data, it's going to be written right away because all of the time windows have expired. So easy enough there. We're going to then write our stream based on our query name of query revenue by city by hour append. That's what we're just calling the query. We provide a checkpoint location based on our path up here. We're going to trigger now with it being available now. In other words, as soon as this runs, what data is available is going to be processed, and then the stream is going to be finished. We'll put the output mode in append mode, and here's our table revenue by city by hour append. So what happens now if we query from our revenue by city by hour append? I'll go ahead and run that query. Here's our results now, exactly what we had up here in the data frame, except that now we have a table that's being persisted to the metastore and is ready for us to continue to work with downstream as needed. Actually, before we get to the update mode, let's actually look at the history, right? So the transaction history of this Delta table. One of the things I want you to notice, for example, if you were just to do a run all on this, you may find that this query, this table itself doesn't have data yet. And that's because the streaming queries need to be started up, initialized, ready to go, and then provide data. And that takes a certain amount of time. So if we had done a run all, we might find that this table contains no data. And we can see that in the transaction log when we see that the table was created. We had a streaming update and then another streaming update. We see that there was a certain amount of time transpired, right? This was at 42 minutes and 3 seconds. This was then 22 seconds later. This was about 20 seconds later, roughly. So there's a certain amount of time required before those updates will actually be written to that table. That's just because we were wanting to initialize this streaming data frame. All right, now contrast that with writing in update mode. Now with update mode, the results are going to continuously be updated, and then as soon as that window time expires, then we move on to the next window. We'll continue to write those updates to the table. But what we're going to do now is we're going to use a merge command and a for each batch function call. Let's talk about that as we step through this code. Go ahead and run this cell. In fact, I'm going to go ahead and run the next cell down too, because that's going to take a little bit of time to initialize those streaming data frames. No big deal. All right, so we will import now these specific types because we need to create this table first. Now, normally in production, in the real world, quote unquote, you probably will have already created your table at some point in the past, and now you're just going to be doing your upserts, right? Your updates and your inserts as time goes on. But in this case, we don't have a table ready to go, so we're going to use that create table statement, or I should say the create data frame in this case, because we're doing structured streaming, and I need to provide the schema. So what I'll do then is I'll import the pyspark.sql.types, these specific ones that I'll be using within the schema. I'll define the schema now as a struct type. Within the struct type will be a struct field. It'll be window, and that struct type then is a struct field that's a start, which will be a timestamp type. They'll have an end that'll also be a timestamp type. I'll have a city that'll be a string type. All of these you can see how they're nested within one another, and that's based on how this data is currently sitting inside my data file. So what I'll do then is I'll create an empty data frame using spark.createDataFrame. It'll just be empty, as you can see here, but I'm specifying the schema so that I won't have any data inside the data frame, but I will have a schema associated with the data frame. Then what I'll do is I'll go ahead and save that as a table, and the name of the table will be revenue by city by hour. All right, so here is my function, which I'll actually use to perform the upsert in these little micro batches that will come as a result of this streaming data frame. So we define the function upsert to delta. We're going to use that in a couple of cells. We receive a data frame, a micro batch data frame in this case. but we'll name it microbatch output df. And then we have a batch ID as well. We will set this data frame to a view name. We'll just call it updates, and it'll be a temp view. And then we use microbatch output df, the one that was passed to us, .spark session.sql, and we'll basically just use this SQL, right? So it's the .sql, meaning that we're going to call essentially what would be spark.sql, the function that we can provide, and have it apply to that microbatch output df. The SQL that we're going to provide is a merge into our revenue by city by hour, which is the data frame that we created up here, revenue by city by hour, which was currently empty. We'll just alias that as T. And then we'll use our updates, which will be S. And of course, this is our updates right here, the view of our microbatch output df, aliased as S, on, and we're going to examine the T, right? So the revenue by city by hour, window.start being associated with the S, meaning the updates window.start, and the ends also being associated with one another, as well as the cities being associated with one another, right? We're going to examine those relationships when they're matched, right? And when I say relationships, I want to see, it's not like we're setting these equal or we're trying to determine if they're equal. We're essentially saying that we want to perform a comparison on these. When they're matched, then we're going to update and set star, meaning all the information or all the columns from that microbatch data frame. So when we get a match on the window start for both of them, the window end for both of them, as well as the city, then we know that already exists within the table. We don't need to append or insert, right? We need to update. So we'll update set star. When any one of these is not matched, then we're going to insert star, right? So if we don't have a window start and a window end and a city that are all matched within that revenue by city by hour table, then or data frame in this case, then we're going to get an insert, otherwise we'll get an update. All right, so let's go ahead and look now at our revenue by city by hour. We see that it's empty. That makes sense because all we've done is define a function. We haven't actually done anything with it just yet. So let's go ahead and do a write stream using the same checkpoint path that we've used in the past. No big deal there. We're going to do a write stream, and then we do a for each batch, which means that as data is received, it's going to send that data to our upsert to delta function that we defined right up here. It's going to go through that whole process, look at these three items or these three columns, these three fields. When they're matched, it'll update. When they're not matched, then it's going to insert on each of those batches. We put the output mode in update. We give the query a name, provide the checkpoint location, and we'll use that available now trigger as well, so that when we run the query and there's data available, it'll just run through. And then we grab start, or I should say not grab, we run start to make the thing work, right? Make it happen. We go with select star from revenue by city by hour, and we see now that we have data in here. Now this data would continuously be updated as well. I totally understand that this is old data from years ago, but if we had new data coming in and we had a window that already existed, a city that already existed, then the row would be updated and we have a new total revenue dollar amount. So pretty cool stuff. If we look at the history now, you'll see the difference between these two transaction logs in the Delta transaction log. We still have the create table, but notice now we have a merge operation because that's what we were doing, was merging the data. If we look at the transaction log for our first table that we created, there it is, you can see that we had a streaming update, right? So a streaming update as opposed to a merge, where when we are updating or performing upserts, then it'll be called a merge operation in the Delta log. Very cool stuff. We can run this cell now. That will stop all of the streaming data frames that are currently in the session. And we can run da.cleanup to erase other things that we need to in the lab environment.